When we learn about exploratory data analysis, it's very important that we understand why we do this. When we think about data analysis, we commonly think about this a five-step process. This is also mentioned in a textbook called GIS Spatial Analysis. And if you look at the chapter 1, model basically says there's a five-step process. First, you're going to impose a question, and then you look for data, and then you basically choose the methods, and then you do analysis, and the last thing you basically analyze and then report it. Okay? So this is kind of a very linear way to understand what the data analysis is about. However, in reality, we may have a number of issues in applying that methods. First, we may or may not know what question to ask, okay? Especially for new domain or new field that we have very little understanding, but we have a lot of data. In that case, we may need time to get to know the data and let the data tell us what we can find out, rather than imposing a very specific question first. Second, usually the data analysis is not following a linear process, and usually take a spiral process where you start with very general idea of what you want to accomplish, and you have a few little more detailed questions, but it's not really detailed enough for you to do the analysis yet. But then after you look at the data and you find that your assumption may be wrong, or you may have a better idea of what the possible question you can ask, and then you come back to reformulate and enrich your questions. So in that case, you see this, there's a circle between exploring data and then refining the questions and then come back to analysis. So this kind of process is more natural in many cases. Recognizing the unlinear and spiral process of data analysis, exploratory data analysis is trying to support the phase where the human analysts have to spend time understanding the data, or kind of get to know the data, and have time to explore what the right question to ask. So in this case, we're talking about tools that can support us to explore the data rather than ask questions to the data. So we try to listen to what data can tell us and stay open-minded in order to see something that we didn't expect to see. When we talk about exploring data, it's very similar, in fact, to exploring any new space. For example, if you come to a new town, the usual process that you want to look at what are the available things you can do. And you take a map and you see the overview of this whole town, and look in different part of the town and see which parts you want to explore more. Okay, so you decide what are the relevant things you want to focus on. Okay, so there's a process you select and choose, and then you move on to look at details. For example, you look at maybe any movie that is shown tonight, or there's a park, there's a lot of activities, and then you go into explore those details. What I just described is exactly the pattern we know about information seeking, and that shows human always start with the process of exploring the space, and then focus on asking questions in particular. So in information science, we tell two different phases of interacting with information. One is called exploration, and second is called searching. Okay, so exploratory focus on looking at big pictures of the data and looking at the overall view of the collection, and try to figure out which parts you're more interested or you're likely to take a closer look. Okay? And only until you have very specific question and you want to really pick up a subset, then you turn into the searching mode of interacting with information, where you formulate your query and try to extract a subset. So EDA represent the first stage of getting to know your data. So exploratory data analysis is very different from data query or searching. So in what way is different? We can think of EDA as having a very different set of objectives. One objective is to be able to look at the data and coming up with general observations of the patterns of phenomena or the process that could possibly become the hypothesis for you to continue more theoretical investigation. The other use of EDA is to, if the data meet the assumption that made by your methods or by your study. For example, certain statistical inference require that the data needs to be either normally distributed or following a Poisson distribution. So if the data doesn't really follow that assumption, then we cannot select those analytical methods. The third thing we can use for EDA is to determine whether there's a data gap or there's a missing piece or there's additional detail we need to look for. So we really are looking at the need for additional data collection. One of the fundamental methods in EDA is to rely on both the statistics and the graphics, because statistics give you a general description of the data, the nature of the data, and the graphics can allow human to perceive in a very intuitive way them connected with the actual statistical measure. So the data analysis in the exploratory mode represent a very different way to look at data. Instead of using statistics to confirm hypotheses, we actually use statistics to describe patterns and discover something that is could be a surprise.